Hello everyone. So we are going to start the part 6 of distillation. So in this part we are going to deal with some of the other distillation method, or you can say some of the other distillation apparatus. So first of all, the destructive distillation is also known as the dry distillation. As the name itself it reveals, it is dry, means here the distillation it will be continued or it will be taken place in the absence of air actually. So you see the distillate which you will get after the distillation, it is the decomposition product of the constituents of the organic matter burned in absence of air. Moreover, it is generally not preferred in our laboratory practices, but it is very much essential and useful in the industrial processes to obtain the valuable product from the wood as well as coal and animal matter. Right? So it involves the heating of drying matter in suitable vessel in the absence of air. You just need to remember that the destructive distillation means the distillation which is taking place in the absence of air. So the distillate, it is the decomposition product of the constituent actually. The distillate which you will get in this process, after the process of the distillation, the distillate it is the decomposition product of the constituent. So wood distillation industry and the coal carbonation industry, they provide actually many useful fuel material with this type of distillation, that is the destructive distillation. Next we have the compression distillation. So generally this compression distillation process it is applied for the desalination of the seawater. We all know that we have a scarcity of water, that is the drinking water. So this is a very useful method to convert the seawater into potable drinking water. So you see the compression distillation method, it was developed to meet the need of the Navy and the Sea Army for fresh water from the sea, right? So the product which you are going to get in the compression distillation, it is pure, moreover it is pyrogen free. Therefore it meets the requirement of all the pharmaceutical industry, because for formulation of different pharmaceutical dosage form we need to have the water that is of high grade, means it should be highly pure as well as it should be pyrogen free. So for generally for making the parenteral product, the water that is being used for making the parenteral product, that should be pyrogen free, and the pyrogen free water can be prepared with the help of the compression distillation method. This method is economical from the standpoint of consumption of fuel and water. And how this method actually takes place, let's discuss. So what actually happens here, the feed water, whatever water you want to distill, the feed water it is heated in a evaporator for boiling. Right? The feed water, the water which we want to distill, it is actually heated in the heater, or sorry, it is actually heated in the evaporator for boiling. So after boiling, what actually happen, the vapor pressure will be produced, right? So that vapor pressure that is being produced after heating, the vapor that is being produced after heating in tubes, it is separated from the entrained distill in the separator. Means after the production of the vapor it is immediately separated from the heating chamber, right? So now this vapor is then conveyed to a compressor. So this vapor after means formation, after the formation of the vapor, this vapor it is immediately transacted to a compressor where this vapor will be compressed. So once this vapor will be compressed, the temperature will be rises, right? The temperature may reach up to 118 degrees centigrade. So it then flows to the steam chest. There is a design actually, there is a steam chest. So afterwards, after getting heated to 118 degrees centigrade, this vapor it is now allowed to move to the steam chest. In the steam chest, this vapor it condenses on the outer surface of the tube. Steam chest, it is just an arrangement of tube. So in the steam chest, this vapor they will now condense on the outer surface of the tube. So during the condensation, the heat is released, right? So which is again will be used to heat the newly fed water. So once the vapor it will release the heat after the process of condensation, the amount of the heat that has been released, it will be reused. The amount of the heat it will be reused for boiling the fresh feed or newly given water. So the vapor it condenses and drain off as the distillate in this process. The next one, it is the fractional distillation. See, the name itself it says fractional, means different fraction. So the fractional distillation, actually what happens, this method, the fractional distillation method, it is also known as the rectification method, because a part of the vapor it is generally it is condensed and returned as a liquid fuel. It is returned as a liquid. So whatever the liquid you are going to heat, a part of the liquid will again come back to this chamber as a liquid, right? So this method it is used to separate miscible volatile liquid. I repeat, this method can be used to separate miscible volatile liquid. For example, the mixture of chloroform with benzene, the mixture of acetone with water, these are miscible volatile liquid, right? So they can be easily separated by using this fractional distillation or fractional distillation. Moreover, the fractional distillation, it is a process actually in which the vaporization of the liquid mixture gives rise to a mixture of the constituent. When this mixture, suppose water and acetone, when they will get heated, they will produce the vapor, right? This vapor will have the mixture of the constituent from which the desired one is separated in the pure form, right? So you can see here, this is the fractionating column. This is the fractionating column. So once you are going to heat the water, it will be heated, right? The more volatile component will reach at the height, so it may get settled here or it may get condensed here, right? The less volatile will come here, because it is the less volatile liquid will come later on, whereas the more volatile liquid will come faster and it will reach the top. It will be generally settled at the top of the fractionating column, whereas the less volatile they will be settled in the lower part of the fractionating column. So what is the basic difference between the simple distillation and fractional distillation? See, in the simple distillation, the vapor pressure it is directly passed through the condenser, we know that, right? But in the fractional distillation, the vapor pressure it must pass through the fractionating column, in which partial condensation of the vapor is allowed to occur. So just remember, in the fractional distillation, the vapor must pass through the fractionating column, in which the partial condensation of the vapor is allowed to occur. The next difference between these two processes is that you see the condensate is collected directly into the receiver. In the simple distillation process, the condensate means the product which you are going to get after the condensation, that is the condensate. The condensate is collected directly into the receiver. But in fractional distillation, the condensation takes place in the fractionating column, right? So that a part of the condensate vapor returns to the still. See, the condensation takes place in the fractionating column. So a part of the liquid it again come back to the still. This is the still, right? It may come back because it has condensed here. So after condensation, it may become liquid. It can get poured here in this still, right? So simple principle. So when a liquid mixture is distilled, the partial condensation of the vapor is allowed to occur in a fractionating column. So when a liquid mixture is distilled, the partial condensation of the vapor is allowed to occur in a fractionating column at this point, right? Moreover, in this column, ascending vapor from the still, this is the still, right? Ascending vapor from the still is allowed to come in contact with the condensing vapor returning to the still. The ascending vapor here, the ascending vapor, it is coming here, it will come in contact with the condensed vapor, because see, once I have started the process, suppose I have started the process, immediately what will happen? The more volatile will come here, the less volatile will come here, they will start condensing. But the process it is going on, right? The next portion of the liquid which is coming here, they will produce the vapor. Now this vapor will come in contact with the condensed vapor, right? So they will remain in contact with the condensing vapor while returning to the still. So the result is enrichment of the vapor with more volatile component. So the vapor pressure or the vapor amount will get enriched in this process. So by condensing the vapor and reheating, so you see here we have condensed the vapor in the fractionating column, and again we have reheated them here. To reheating the liquid repeatedly, equilibrium between the liquid and that of the vapor is set up at each stage, and this ultimately results in the separation of more volatile compound, because the more volatile component will finally come out from this still or from this apparatus. So the next thing is that application. The fractional distillation, it is generally used for separation of volatile miscible liquids which near boiling point, which are a volatile liquid mixture of acetone and water. And I have already told you, mixture of chloroform with benzene. But it also have a disadvantage. This method cannot be actually used to separate miscible liquid. These are immiscible liquid. This acetone, water, and these are immiscible liquid, right? But sorry, these are actually miscible liquid, but they are not azeotropic mixture. But you cannot use this process to separate immiscible liquids which actually form pure azeotropic mixture. The chloroform and benzene did never forms a azeotropic mixture, or the water and the acetone, they never forms a azeotropic mixture. But if they forms a azeotropic mixture, suppose here along with chloroform we are using some other component, then it's like your chloroform and ethyl ether or something like that, then if it forms a azeotropic mixture, in such cases this fractional distillation process cannot be performed. Thus coming to the end of this slide. So thank you everyone, hope you like the video. If you like the video, just press the like icon. You can share this video with your classmates and colleagues, and for further notification from this channel, do subscribe my channel. Thank you once again.